what are you doing?
Hi Max, I think I have some problem with this question. You know what is differentiation is? You know what is the technique of differentiation? Can you give me explanation about differentiation?
I think I know this one. Let me explain to you one by one. Now, what is the differentiation? The differentiation is a mathematical process to determine how a function changes as its inputs change. In other way, if y as x, the derivative dy by dx measure the rate of change of y with respect to x. This differentiation is useful in many areas, such as in physics, we can calculate how to find the velocity, and in subject economy, we can find how to marginal cost. Now we move to the technique in the differentiation topic. First one is the quotient rule. This quotient rule was used when differentiating a function in the form u over v. So this is the formula. Now we move to the second is the product rule. This product rule was used when differentiating the product of two functions. This is the formula. Now is the last but not least a chain rule. The chain rule was used for composite function f in bracket g in bracket x. So here the formula also. And last but not least also, we have a sum and difference. Sum rule d over dx. This is the formula, and the different rule is this one.
Okay, hi. Today I will explain about question 2, which is the find dy dx for the following function. A. Y is equal to x cubed exponent tangent to x. Okay, we're using product rule, which is the u prime plus vu prime. From the equation, we let u as x cubed, u prime, we differentiate, we get 3x square, v e tangent to x, and v prime e tangent to x times d over dx tangent to x, and we get e tangent to x times 2 sec square to x. Okay, from the product rule, we substitute the value, we get this one, and then after we solve this, we get the e tangent to x from each of the variables. So we took out the e tangent to x from the bracket, and then after that we took out the x from each variable to get x squared exponent tangent to x in bracket 3 plus 2x second square to x. Okay, next is question B. Y is equal to ln sin x over square root of x cubed plus 5. Let u ln sin x and v is equal to square root of x cubed plus 5. Then from the you want to find the u prime by using the d over dx ln sin x. We got the cos x over sin x, which is cotangent x, and for v prime, x cubed plus 5 power of 1 over 2 from the square root, and then we put the 1 over 2 to in prime minus 1, and we get this, and 3x squared from the differentiation of x cubed. Then we get 3x squared over 2 y prime is equal to u prime v minus uv prime over v square. We substitute the value of u prime, v prime into the equation, and then we solve the equation, then we get this. That's all.
So now we will solve this question 3, which is dxy plus ln x plus y equals to sin xy plus 3. Find dy dx using implicit differentiation. Okay, first step, we must differentiate each part 1, 2, 3, and 4 by dy dx. Okay, first step, differentiate dx. This one we get this. Second, this we get this. Second, third here, and then we got cos xy from sin. Then the last one x power 3 here. How we get that is u v prime u prime v prime. Second step. Okay, we write the formula dxy bu prime plus uv prime plus u prime plus v prime over u plus v equals to this one, this value. After that, the step 3, after we times this with the inside the bracket we got this, right? And then like usually we got this. After that, all the dy dx we must make it at the right side so we can solve the problem. dy dx, dy dx, dy dx, and then let this be the normal number. This is the last step, which is step 4. We make it dy dx at the outside of the bracket, like this. dy over dx, then equals to find this value. So how to find dy over dx? This divide to this. So we write back like this. So this is the final answer, but we make it in the simplest way. So we make the y outside here and here. We basically simplify it, and then the answer is this. Thank you.
Hi! So we move to the next question. The question is about use linear approximation to estimate the value of ln 1.02 minus 2 divided by square root 5 of 1.02. So the first step is you must rewrite the given expression as a function. Fx equals to ln x minus 2 divided by x power of 1 over 5. So x is the given value of 1.02, whereas square root of 5 is equal to x power of 1 over 5. The second step is we differentiate using quotient rule. Why we use quotient rule? Because this expression consists division of two functions. So this is the step. After we differentiate, we will get this expression. So the third step, from the given value x equal to 1.02 and the x null is 1.00 because 1.00 is approximate to 1.02 and the delta x is 0.02. And the final step, with the value of x null and delta x, we use the formula of differential.
So by applying linear approximation, now we can substitute the value of x null and delta x to the respective function. And the final answer is negative 1.972. In conclusion, differentiation plays a central role in calculus as it allows us to measure how quantities change and to analyze the behavior of function in a precise and systematic way. Throughout this presentation, we demonstrated several key techniques of differentiation, including the product rule, quotient rule, and implicit differentiation, as well as the application of linear approximation for estimating values near a known point.
We differentiated a composite expression by applying appropriate rules step by step. In question 3, differentiation allowed us to handle an expression where x and y are independent. And then, for question 4, we used linear approximation as a powerful method to estimate difficult expression without using calculator. Altogether, this method illustrates how differentiation provides both theoretical understanding and problem-solving strength. Thank you.